Hello all students, so we came to our lecture 2 of this bearing design. So as you all know that Petroff's equation are the basic equation for bearing friction calculation, and this work has been published in 1883 on the bearing friction based on the simplified assumptions, which are no eccentricity between the bearing in general, means there will not be any kind of wedging action in this in between bearing and general, and oil film will be stable to support the load, and the no lubricant flow in the axial direction, means in the axial direction there will not be any kind of flow. And this is the unloaded general bearing picture. As you can see here, this is the diameter small d, and this is the capital D, the diameter of the whole general, and this is the C, between the clearance between these two things, and it is rotating with a speed of a small n. Now, as you all know, according to the Newton's law of viscosity, the force or viscous force will be F is equals to mu into AU by H, and the where F is your frictional torque divided by radius of rotation, which is 2 into Tf by d, and the area is pi dl. You have already calculated, and U will be equals to pi dn, where n is the RPS and d is in meter. So keep this thing in your mind that n should be in RPS, revolution per second, and d should be in meter, not in mm. And h should be equals to c, where c is radial clearance, which will be equals to 0.5 multiplied by d minus d, the difference between these two things. R will be equals to small d by 2. If you will keep all those value in this formula, then you will get the value as Tf will be equals to 4 pi square into mu into n into L into R cube divided by C, and the torque will be also equals to F into W, where F is your frictional coefficient and W respective of the wear. So that will equals to 0.5 into F into DLP into D. So if you will equate equation number 2.2 and 2.3, then you will get the value as F is equals to 2 pi R square mu n by P into R by C, and this is known as Petroff's equation for bearing friction. And these two terms, mu n by P and R by C, these two are dimensionless parameters of the bearing, and clearance ratio normally ranges from 500 to 1000 in the bearing. Now moving towards a problem which you should understand, means how you can solve the bearing related problems. So first, see what is the problem given. It is a machine general bearing has a general diameter of 150 mm and length of 120 mm. The bearing diameter is this 150.24, means 150 and 150.24. This will give you the value of clearance, and it is operating with a SAE 40, means the properties of lubricating oil at 65 degrees C, and the shaft is carrying a load of 8 kilonewton, and it rotates at 960 rpm, which you should convert it into RPS. Estimate the bearing coefficient of friction and power loss using Petroff's equation. Means you have to calculate the bearing coefficient of friction, means small f, and power loss using the Petroff's equation. These two things we have to calculate. So what we should do first is we have to note down all the given data here, which we have quoted like this: D small capital D, L 0.12, and F is 8 kilonewton. SI 40, and temperature means initial temperature is for 65, and N is in the form of RPS, it is 16, and Q1. F we have to calculate small f, and N loss, which is power loss. Now we have as per the data, we have re-evaluated the data like this. Now the viscosity of SI oil for 65 degree, means this will give you the value of mu, and if you got the value of mu with the help of these diagrams, means this is your diagram of viscosity temperature curve of SAE graded oils, and we have taken SAE graded oil of SAE 40. Now if you will see that at a point 65, because the temperature is given as 65, we have drawn a vertical line, and which is going to touch the SAE 40 value, SAE 10, 20, 30, 40, and at SAE 40 we have drawn a perpendicular at horizontal line. Then we have find out it is at 3, and it is in megapascal second, or CP means in centipoise or megapascal second. So if we will convert it into Newton second per meter square, then you will get a value as 30 into 10 to the power minus 3. Now we have calculated F according to your Petroff's equation, which we have studied in this lecture before. I will recall this. So this we have equated equation number 2.2 and equation number 2.3. Then we got the value of F. So F is 2 pi R square into mu n by P into R by C. So with the help of this formula, we have calculated the value of friction. So friction value will be calculated with the help of this formula of Petroff's equation and with the help of this chart, which is viscosity temperature curve. Now we have to calculate the value of friction torque, which is TF is equals to small f into capital F into R. Capital F is your load, 8,000 is given, small f is we have calculated, R is given already. So we are ready with the torque. Now omega is required to calculate the power loss. Omega is 2 pi n by 60, which we have calculated in the radians per second. Now the power loss will be equals to, if you will multiply your frictional torque with the angular velocity, then you are ready with your power value of your power loss, how much power loss will be there. Now moving towards the hydrodynamic lubrication theory, and basically this theory are having some assumptions and it has been developed by Sir Reynolds. So what are the assumptions which we have to look after whenever you are doing or studying this theory is, the fluid should be Newtonian, the fluid is incompressible, and viscosity is constant throughout the film. The pressure does not vary in the axial direction. This is the major thing you will find out, that pressure does not vary in the axial direction means all the pressure should be in the radial direction only whenever you are studying the any kind of hydrodynamic lubrication theory or the theory related with the general bearing. So bearing and general extended infinitely in the z direction means no lubrication in the z direction. Film pressure is constant in the y direction, that is pressure depends on x coordinates only. Velocity is only dependent on x and y. Effect of internal and gravitational forces is neglected, and fluid experience a laminar flow means there should not be any turbulent or any other flow. That should always be laminar whenever the fluid is flowing inside the general. So as you all know, if you will see the picture first, that this is your fixed bearing at the outside, and this is the lubricant flowing inside, and this is your rotating general, and this is the lubricant flow direction. And I have taken a small component as dy and dx. Then if you will apply the loads or apply the forces, then this is the value of, or this kind of picture you will find it out. And if you will balance it into x and y direction, then you will find out forces balance in the y direction, or for the equilibrium of forces in the x direction, then you will find out this equation means py dy dz plus t dx dz plus p plus dpy dx into dx into dy by ds, which is area, and similarly this force in the y direction, and this is dx by dz is area. So this is the equilibrium forces in the x direction. Similarly you can calculate it into or reduce it into this form, dp by dx is equal to d tau by dy. Now the equation of absolute viscosity, as you know, this is mu is equal to fh divided by au. Now and tau is equals to mu into dy by dy. If you will code those all equations, then you are ready with your then you can calculate the value of constant c1 and c2. After substituting the constant, then you will get the value, whole equation will be converted into the with the help of all the derivative equations that you can look afterwards. So this will give you the value of the Ockwick short bearing approximations. And at the last, what is design charts for dynamic bearings? Raimondi and Boyd, these are the design charts which are computerized solution of Reynolds equation, which you have to see whenever you are using any kind of calculation or any kind of designing of bearing. Means at the x side it is bearing characteristic number, which is s is equals to r by c whole square mu n by p, and then by this y side it is minimum film thickness variable. So this you have, these both are these dimensionless properties. So if you know the value of one term, then you can calculate the another term with the help of Raimondi and Boyd curves. So these are the computerized solutions. And similarly here, this is the, another position, means the position of minimum film all thickness phi you can calculate if you know the value of bearing characteristic number, which is rc into r square into mu n by p. This is the whole term which we have seen in the Petroff's equation, the formula of friction. If you multiply this by 2 pi square, then you will get the value of friction as per the Petroff's equation. And similarly there are various curves given by the Raimondi and Boyd that you can see according to your need of the numerical or according to your design of the bearing, that you can see. Like if you want to calculate the flow ratio, then you know the value of bearing characteristic number, then you can calculate with the help of these curves. So there are charts for determining maximum film pressure, charts for determining position of oil film and position of maximum film pressure. And now this is the problem for you which you can solve. A journal of stationary oil engine in 80 mm in diameter and 40 mm long. The radial clearance is this. It supports this much of load, and this is the oil and rotating at 360, and the property of oil is SI 40 at 65 degrees centigrade. Using Remendy and Boyd chart, analyze the bearing assuming that the working under steady state condition, means you have to analyze the bearing conditions, so in which condition it will see. I will give you the answers, just go through it. So with the help of this we have calculated the friction. Now we have utilized to Remendy and Boyd's theorem, which will give you the value of phi, then value of q, then the ratio of this. So basically this is the thing which we have utilized, or I am just go to the your BB Bhandari book. At the back side of the book you will find out all these Remendy and Boyd charts. Analyze those charts, calculate the values, how you can calculate the values for the general bearings if you know the basic data of your things. So these value you have to calculate. So I am binding my content here. Thank you so much for the patience listening. Keep visiting our GECBANSWARA channel for more content related to all the branches of engineering. Thank you.